So, this is an example of using parametric differentiation. If we're given x is equal to 2 root t, y is equal to 3 over root t, find dy by dx. So we're going to use this idea of using the chain rule of dy by dx being equal to dy by dt times dt by dx. So obviously we need to get expressions for our differentials here. Now, before we can do that though, we don't like these square roots and these fractions, so let's turn this into index notation, which is much easier to deal with. So we can say that x is equal to t, 2, t to the half, and y is equal to 3, t to the minus a half. It's when we're in this form then we go and say, right, well, to use the chain rule to find dy by dx, we need to find dx by dt and dy by dt. So, for dx by dt then, we bring the power to the front, the half. 2 times a half is 1, so that cancels. So we're left with t, drop the power by 1, minus a half. And when we differentiate y with respect to t, again bring the power to the front as a multiplier, 3 times minus a half, which is minus 3 over 2. T, drop the power by 1, minus 3 over 2. So it's at this point that we can then use the chain rule. So therefore, dy by dx is equal to dy by dt times dt by dx. Dy by dt is minus 3 over 2 t to the minus 3 over 2 multiplied by, well, dt by dx flips this, so it becomes 1 over t to the minus a half. Alternatively, you could write that as t to the half, okay, and ultimately we're going to simplify this anyway. So, when we combine this together then, we have minus 3 over 2t, and we've got t to the minus 3 over 2, really divided by t to the minus a half, so it becomes minus a half, or plus a half, and minus 3 over 2 plus a half becomes minus 1. And you'd be perfectly fine to leave it in that form. However, we can really write it, if we want it back in a fraction notation, as minus 3 over 2t. Okay? And generally, I quite like in that form, but you would get all the marks if you left it in that form as well.